Alright, let's take a look at solving some three-part inequalities. Notice we have two inequality symbols here, so that separates this expression or this inequality into three parts. So the goal for this is to isolate the variable in the middle. Okay. Often we isolate the variable on one side, but since this has three parts, we're going to isolate the variable in the middle. So we go to the middle and begin to say what would this take? Well, first of all, we need to eliminate this plus 3. So that would take subtracting 3. And we have to subtract 3 from all parts. So that now leaves us 21 is less than 7p is less than 42. To continue to isolate p now, we need to divide by 7. So we need to divide by 7 here and here. Now that gives us 3 is less than p is less than 6. Alright, and on a number line, remember there's a handy trick for these. We could separate these and read this one backwards, read this one forward, make two graphs, and then use the combined graph. But three-part inequalities have a nice trick. If the smallest number comes first and all signs point towards a smaller number, that means p is in between these two numbers. So we're going to graph the solution set. Okay, this is the solution set one way, and we can show it as a graph. One number line representing all possible values of p. We need to mark the number 3 and 6 in number line order. And let's see, p will fall in between those two, so we would shade in between 3 and 6. This actually says p is greater than 3, which is true here, and p is less than 6, which is true here. Do we include 3 and 6? No, there's no or equal to under those, so they get parentheses in the direction of the shading. And interval notation then. Another way to represent the solution set just says a parentheses 3 comma 6. That shows the same information in interval notation. Okay, let's solve the next three-part inequality. Here we have 3x plus 2 is in the middle. Okay, two inequality symbols. So we're going to begin to isolate x in the middle here. So first step is minus 2 for all parts. That gives us 9 is less than 3x is less than or equal to 21. Now we're ready to divide by 3 to isolate x, so divide by 3 all places. And that work shows 3 is less than x is less than or equal to 7. Alright, so this is like the earlier one in that the 3 is smaller than the 7, so the smallest number comes first. All signs point to the smallest number, and we could show that solution set in graph form. One number line, marking in number line order the 3 and the 7. Okay, and we've determined that x will be between the 3 and the 7. X is greater than 3 and x is less than 7. We read starting with the x. Do we include the 3? No, the symbol does not say or equal to, so it gets a parentheses. Do we include the 7? Yes, because it has an or equal to, 7 gets a bracket. Then the interval notation. Opens with 3 and a parentheses, closes with 7 and a bracket.